Mass problems. So they give us a mass of one substance. They ask us for a mass of another substance. So the path for this, is going to be grams to moles to moles to grams. That's like a chemistry chant. Grams to moles to moles to grams. And you need to memorize that. It's not too hard. Grams to moles to moles to grams. And you know you have it down when you wake up in the morning mumbling to yourself, grams to moles to grams. Then you know that you're on the right track. So this is like the standard, the regular type of stoichiometry problem. Each of these, see, this is a path, just like we made paths for unit analysis, right? And for each of these arrows, we need a unit factor. The unit factor for converting grams to moles is called what? The molar mass, right? So we're going to need the molar mass. That's grams per mole. That will allow us to do this conversion for the first substance. And we're going to use the molar mass of the other substance over here. The mole-to-mole conversion is what we just learned how to do. You look at the balanced chemical equation, and the coefficients tell you what that mole ratio is. So here's a real problem. What mass of aluminum is needed to convert 63.5 grams of iron 2 oxide to elemental iron? And the balanced chemical equation is given. You always need a balanced chemical equation for these guys. What I like to do is I like to use this equation to help me organize the information. So we go through here and we're looking for numbers. We get 63.5. They're giving us the name. Now, even if you're a little shaky on your nomenclature, you should be able to pick out the one of these that is the iron 2 oxide. That's this guy, right? So under the formula, I'm going to write the mass. It's telling me I have 63.5 grams of that guy. And what is it asking about? Mass of aluminum. So I'm going to go question mark grams of aluminum. And then I'm going to write out my path. Especially when you're first starting to do these, you should write the path out. So I'm starting with grams of FeO, grams to what? Moles. So I'm going to convert that to moles of FeO. And now I'm going to convert grams to moles, moles of aluminum. And from moles of aluminum, I can calculate grams of aluminum. These calculations can be done in multiple steps. And if that's what works for you, you can do it that way. But I would encourage you to learn how to string it together. I think the less times you have to punch numbers into your calculator, the fewer times you have to do that, the fewer opportunities you have for making mistakes. So we've done our path. Now we follow that same pattern for unit analysis. So the number that we're starting with is this guy right here. 63.5 grams of FeO. For every arrow, I'm going to have a unit factor. There are 3 arrows, so I have 3 unit factors. The path tells me what the units on the top of all those fractions are. Grams FeO to moles FeO to moles aluminum to grams aluminum. I just have to copy the units down. You might want to leave a little space for numbers in there. Okay, so I have these units in the same order copied down here. And then I take the starting unit and I want to divide by that so that the unit cancels out. So I'm going to divide by grams of FeO. It is important to write grams of what? Because you can't cancel grams of aluminum with grams of iron 2 oxide. Moles of FeO down there. That'll cancel the moles of FeO over there. And moles of aluminum to cancel those moles. All the units in first, and then we put in the numbers. I think the one in the middle is the easiest, the mole ratio. That comes from the balanced chemical equation. There's a 3 in front of FeO, so in that middle term, in front of FeO, I'm going to write 3. And in front of aluminum, there's a 2. That was easy, huh? The first factor and the last factor are molar masses. We learned how to do those. Which one's easier, FeO or aluminum? Aluminum. Let's do that one first. 26.98, right? 26.98 grams of aluminum is equal to 1 mole. For the iron, we're actually going to have to do a little calculation. Really encourage you to show your work. It can be kind of sketchy, but just show it. There's 1 iron and 1 oxygen. When we add those together, we get 71.85. That's grams of FeO is equal to 1 mole of FeO. So for this term, the number goes with the gram. It's 1 mole. It's 71.85 grams is equal to 1 mole for that compound. Any questions? Now we just get out our calculators. Start at the left, multiply by the top, divide by the bottom. Times the top, divide by the bottom. Times the top, divide by the bottom. All strung together. 63.5 times 1 if you want to, divided by 71.85 times 2, divided by 3, times 26.98 equals. How many significant figures should our answer have? 3, which is always a good guess, by the way. We're starting out with 3. This one has 4. That one has 4. The mole ratio, though, is exact, because exactly 3 molecules or formula units of FeO react with exactly 2 atoms of aluminum. So with 3 significant figures, I get 15.9 grams of aluminum. Any questions? If you understand unit analysis, this is not a big leap. It's just a new type of calculation. It's a really important type of calculation. Let's do another one. Calculate the mass of carbon dioxide released from 10 grams of cobalt-3 carbonate given the unbalanced equation for the reaction. So we're going to have to balance this, aren't we? Because we need the mole ratio. Well, what element do you want to start with? Cobalts are already fine, huh? CO. There's 2 cobalts on this side, 2 cobalts on that side. How many carbons here on this side? 3. There's this carbon here inside the parentheses, and there's 3 of those units. So 3 carbons, and over here we have 1 carbon. So if we put a 3 here, that'll balance the carbons. Now let's see what's happening with the oxygens. How many oxygens over here? 9, right? 3 times 3 is 9. And I've got 3 oxygens here, and I've got 6 oxygens there. 3 plus 6 is 9. So we're balanced now. First thing you have to do. 10 grams of cobalt-3 carbonate. So that's this guy over here. 10.0 grams of that guy. And they're asking for the mass of what? Carbon dioxide, that's this guy over here, question mark, grams. What's the generic path? Grams to moles to grams. Even the train likes that. So it's going to be grams of what they gave us the number for, to moles of what they gave us the number for, to moles of the thing they're asking about, to grams of the thing they're asking about. You could add a whole bunch of steps in between, but that's like driving from Reedley to Fresno going through the South Pole, right? Why would you want to do that? It's way out of the way. You just want to go as direct as you can. So we'll start with 10. Well, let's be consistent. Let's write out the path. Grams of, see, with cobalt carbonate, you really want to be careful with the size of your O's. So grams of that to moles of that. And yes, I agree, it's tedious writing out all these formulas. Especially when you start out writing too large. And you end up going up the side of the slide. Grams to moles to grams. Now we're just going to follow what we learned to do with dimensional analysis. So we've got 10 grams of that. We're going to convert to moles of the cobalt carbonate. And then to moles of CO2. I'm really trying to fit this on the one line. And then to grams of CO2. These are the units that go in the numerator. And then we put the previous unit in the denominator. Those cancel. And down here, I'll try to write that big old guy in this little tiny space. Those guys cancel. And down here we've got moles of CO2. It's really important to get the units in there because they tell you where to put the numbers. They take all the thinking out of it. The mole ratio is the easy part. Here's CO2, CO33. It has an implied 1. So I'm going to write the 1 in here. And what number goes right here? 3. Then we have to calculate 2 molar masses, right? So for carbon dioxide, it's the mass of oxygen twice, plus the mass of carbon. I happen to know that one. It's 44.01. The other one, I don't run into very often. I don't even remember the molar mass of cobalt, 58.93. 2 cobalts plus 3 carbons plus 9 oxygens . 2 times 58.93 plus 3 times 12.01 plus 9 times 16 equals 297.89. So 1 mole of that cobalt carbonate compound weighs 297.89 grams. Again, start at the left and go across, multiplying by the top, dividing by the bottom. What do you come up with? 4.43? 4.43 grams of carbon dioxide. Any questions? Is it okay that the mass of carbon dioxide is less than the mass of the reactant? Yeah, because there's another product here. So, what happened to the other 5.6 grams? It's this guy right here. We could calculate the mass of that as well, but we don't feel like it, do we? Any questions? Pardon me? There would be a problem if there was more. Yeah, it would appear that you're creating matter. But sadly, unlike some cartoon characters, you cannot actually cause things to happen by drawing them, right? So the fact that you did your calculation wrong does not mean that it actually works out that way. Oh, we've got another one. Do you want to see this one, or are you feeling okay with them? Okay. Doing okay? Yeah, because we've got a couple others that are real similar coming up. Mass volume. Oh, this is a new section.